Okay, so I'm going to be looking at the UART driver from Foundation Services. Here we have some basic examples, reading and writing with printf. You can see that I'm using the MPLAB data visualizer to test what I am working with. Okay, so we're going to configure the UART module, call the example from main, and plot on the data visualizer. Okay, so we're very literally going to be doing a hello world on this kit. So it's a Mega 4809 Curiosity Nano, and let's create a new project. Use the XC compiler. And we're going to open MCC. Okay, so let's go to available resources, select all libraries. Now, I'm going to look for UARTs, and I can see that there are 4 of them on this microcontroller. You can also look for UART, and you can see that what this is an abstraction module that caters to instances of UARTs on AVR and PIC, and this gives you a lot of flexibility and also gives you some basic examples to get going a little quicker. Okay, so let's add this to our project. We're going to need to add a specific instance. You can see that we have the choice of those 4 UART modules. So going back to the kit window, schematics, you can see that our UART is connected to UART 3. So we can select that UART module. The other option here is to select an example, basic read-write, basic write-transmit. So let's use the basic read and write with printf. I think it's a superset of the other examples. Then if we look in Pin Manager, we can see that our UART is on PB0 and 1. So PB0 is TX, PB0 is TX, so that is the right pin, so we got lucky there. Then checking the notifications, it says Interrupt Manager here, Global Interrupt Enable. So if we look at the module itself, we can see that it is an interrupt-driven module. So we'll go to Interrupt Manager and select Global Interrupt Enable. Then going back to the UART module, to check the configuration, what we can do is we can first generate code, go to our project source files, MCC generated files, and under examples, we'll see a UART example. So here it gives us, essentially we have some different examples, a write string, an example printf, reading some characters from the UART, and then a run all. So here are some instructions: enable UART checked, enable transmit, so that's the receiver and transmitter. We want redirect standard IO to UART, or essentially printf support, and you can see that we have these interrupt settings. Okay, so that is our configuration. So let's one more time just generate code. Call UART example from main. So let's just call all of them. And if we build, we'll probably just get a warning that it wants a declaration here. And we can satisfy that. Generally, we would recommend cutting and pasting example code into your application. See this video as an example. The reason is so that you can build on and modify the example snippets, which get written over every time you generate with MCC. Okay, so we're going to test this in the data visualizer. You can see that the kit detection works just as well here. We are going to send this to a terminal, and we're also going to plot raw. So you see it's COM9, which is connected to the graph now, and we also have the terminal. So now if we program, okay, so we get something with test here, 1, 2, 3, and we can say hello AVR. You can see what we typed is echoed back to us, and at the top we have some raw data. You can see that we are getting this test here, but it's getting cut off. The first few characters are not displaying properly, so we can add something here. And let's start with a new line at the beginning. We can see that our count here is incremented before the test. We can add that here. and 5, so it should display 5 times. And UART read is checking the size of this buffer here, memset, and that buffer is defined up top here at 16. Okay, so let's program again. Okay, testing, transmit, testing, 1, 2, 3. And you can see that that worked well with the /n at the beginning, and then it all looked good. So that was very literally Hello World with Foundation Services. Thanks.